So we discussed about the basics. Then we have this. In yesterday's session, we discussed about the if and if statements, if and if, loop and loop, do and do. These all are called control break statements. We discussed about the control break statements, and now we will discuss about the system fields. So system fields happens to be very interesting and useful concept. Okay. So system fields. What are system fields? System fields are those in which you neither have to declare, nor assign values. So you don't have to declare it, nor you have to neither have to declare it, nor you have to assign the values. Automatically, system will do it. So if I say write sy datum, today's date will be printed. Okay. So in this way, we have lot of system fields which we can make use of. Okay, I'll be giving you the list of all the system fields later, but I'm going to use couple of system fields in our program today. Let me log in again. System fields, create, write sy datum. So if I say sy datum, then today's date will be printed. So in this way, we have a lot of other fields. Let us see that fields also. Let me first show you the output of this. So 13/8 to the 2021. So if you execute the same thing tomorrow, obviously the date will be to tomorrow's date. Okay. Now next we have something like write /sy hyphen uzeit, sy hyphen uzeit. Today's time, present time will be printed. Okay. It will come in the next slide. Right. Sy uname, right? Sy hyphen repid, report name, right? Sy hyphen cprog. Cprog is program name. So there are different types of programs, and in that, one of the type of program is report repid. Okay, so we have all these other different types of programs. We will now just say syntax activate. So this is the time, this is the date. First one is the date. Second one is present time of the server. The server's time right now happens to be 12:38. Okay, it's configured in some other time zone. So 97 user 21 is the login with which I have logged in, and this program name and report name both are same. That happens to be ZVA underscore system fields. ZVA underscore system fields one. This is what. Okay, so these happens to be system fields. This one happens to be system fields. Now we will go ahead, and these are very much useful for us in the future wherever we want to type some default values, and we can also check the status. For example, page number. You want to print a page number, you can go for one. Okay, and that way we have a lot of things. We'll go ahead now. Okay, system fields, and then we will go ahead with different types. How do we actually comment it? Comment the lines. We need to know how to comment the lines. Commenting the lines. See, mainly why we use the comment of lines, just for our understanding. See, I want to write what is the reason I am creating a program. I want to write the information about why I am declaring something. So all these things happens to be something which will be doing it in the write statements. So we'll be writing. See, if you want to comment entire line, comment entire line, we have to start with star. Start the line with star. If you want to comment a line with in the middle of the line, if you want to comment, then you should start that at that particular line. We have to put in double inverted quotes. So when you keep a double inverted quotes, from there it becomes a comment. Okay, in the middle of the line. So let's see that. So commenting will actually allow you to give some information. Let's say I want to comment like here, today's date. So I'm writing in the middle of the line, so I have to give double inverted quotes. But if it is the beginning of the line, then we will be commenting like, we'll be giving a star, and star will not work in the middle of the line. Star will work only at the beginning of the line. So this is like present time. This is present time. I've just given this. Now you can just say save. Okay. So now that has nothing to do with the output. Okay. It has got nothing to do with the output. Now let's say we have to comment multiple lines. Let's say you want to comment all these lines. Okay. So there are 100 lines that you want to comment. You cannot comment at it just like that by keeping star for every line. All that you have to do is just type control lesser than. If you type control lesser than, then the entire lines will become comment. Then if you go for control greater than, okay, so what did I do? I used control lesser than, select all lines that needs to be commented, then control plus less than, control plus select all lines, and for commenting, and for uncommenting, control plus greater than for uncommenting. For uncommenting, it is control greater than. For commenting, control less. So you can try it out now. You can try out these things. You can try out these things. Okay. Now Now we'll go ahead with uncommented control plus little bit then, and we will go ahead with yes, Lucy. Go ahead. What's your doubt? You can ping me in the chat or you can ask me. Hello, Lucy, are you asking me? Three-tier architecture concept is not completed for you all, I guess, Lucy. Three-tier architecture is not completed, I guess, but okay. Okay. So let us actually this three-tier architecture. I have to explain you. So what is three-tier architecture? Let us discuss that now. Okay. So what is three-tier architecture? Now let us take from our day-to-day life. Okay. One-tier architecture. See, if you have a desktop or a laptop, okay, if you have a desktop or a laptop not connected to any of the networks, it is neither connected to internet, neither connected to any LAN connection or anything, then it is called one tier architecture. Then we have two tier architecture. Two tier architecture will have the server and then we have client. So this is called client server architecture. So in the client server architecture, we'll have one server, and on that server we have all the clients. Okay, so in this way, what happens is like if some 10 people are working in a network, they can have one server. So this happens to be a kind of a client server architecture. In client server architecture, what happens here is that we will have, so in this way we can connect all these things. So here we have C1, client server, client 1, client 2, client 3, client 4, and here we have the server. Server. Now this server, on the server, we are writing all these clients. So these are all the clients that we have, and this is the server. Okay. Now these are all connected. Now the advantage of having the client server architecture is that if you okay, so client server architecture is if you want to save a file in the server, if you actually save a file in the server, that can be accessed by any of the clients. Okay, that can be accessed by any of the clients. This server can be accessed by any of the clients. Okay, this is the advantage of going ahead with the client server architecture. Now in this, like we can go ahead and use that. So there are some drawbacks of it. Okay, advantages. What are the advantages? You can save one file here that can be accessed by everyone, and if anyone modifies also, we can see that changes in the server immediately in the other clients. So there is an advantage of two-tier architecture. But the issue with the two-tier architecture is, the problem with two-tier architecture is, in the two-tier architecture, if the number of clients have been increased, suddenly this is designed for 100 clients, and suddenly 200 clients log in, then the server will become slow. Server becomes slow, and the server becomes slow, and also sometimes it completely hangs up. So there is an issue of that. Performance issue will come. So to avoid that kind of a performance issues, they introduce another tier in middle of this server and client, that is called application tier. That is called application tier, which we are going to discuss. So now this all what we have in the front end are called called presentation tier, and here in the server we have the database tier. This is what we have. So the presentation tier has all the front end users. Okay, it might be a desktop or a laptop. Those all are front end users. Then in the down below we have the database tier. In the middle we have the application tier, wherein we are interacting with the dispatcher, and then we have the work process. Okay, so we have the database tier, application tier, and presentation tier. This is what we have. So in application tier, we have the dispatcher, and we have the work processes. Okay, now let us understand about the significance of application tier. Because presentation tier is clear, we are going to connect to all the the dispatcher, and we have the database is also clear. The application tier is what we need to understand more in detail. Now, the communication from the front end to the database happens through dispatcher. It happens through dispatcher, and then we have the work processes. And these work processes actually will take work at a time. So let's say we have 3 work processes. At any given point of time, only 3 work processes go and hit the database. So the load on the database is always maintained. There's no situation where there will be huge load on the database. But the dispatcher will actually keep all the requests, the additional requests, on hold. Okay, that is called queue, being in queue. So it keeps all the additional requests in the dispatcher, and from here it takes it forward to the database. So let's say we have 3 work process and we have 4 requests. The fourth request will be in the queue. As soon as any work process becomes free, it will take care of that work. As simple as that. Hope you have got this. So the central process in the RG application layer is the dispatcher. Together with the operating system, the dispatcher controls the resources of an RT system. So what is the main task of the dispatcher? To distribute the workload to the work processes and then give back the answers, or give back the response to the presentation layer. This is what we have. So the dispatcher distributes the requests one after the other to the available work process. Data is actually processed in the work process. So once the data has been processed, the processing results from the work process is sent through the dispatcher. Now here there will be two types of commands that we are going to use in ABAP. One is OpenSQL statements and native SQL statements. When I say OpenSQL statements and native SQL statements, these have nothing to do with the SQL language. There is something called SQL language, which is a separate language altogether. So it has got nothing to do with that. It has got nothing to do with that. SQL language is different. SQL commands in ABAP is different. So please understand that. Okay. So I will explain about the OpenSQL commands and native SQL commands now. Okay. I'm just waiting for a minute so that if you want to make a note of it, you can do it. And I'm going to explain this screen. Okay. Okay. So now, let's say you want to get some data from database table. Remember, data will be always stored in the database table permanently in database tables. Now, this data will be actually accessed from our application tag through ABAP programs, and the data will be stored here temporarily and not be permanent. So, how the data is stored in local buffers? It will be stored in internal tables. So, we have seen that a data is getting populated to internal tables, but internal tables data is all temporary. Only during the runtime you'll have it. Only during the runtime you'll have the data in the local buffers. Okay. Only during the runtime we'll have the local buffers. You'll have the data in the local buffers. Now, after once you come out of the program, there will not be any data at all. So you have two options to get the data. One is through OpenSQL statements. Now, how does OpenSQL statements work? We need to understand. That's very important. See, OpenSQL statements work in the form of one-time process. See, if you want 1,000 records from the database table, now the OpenSQL statement goes and brings all the data at once to the local buffer. It keeps it stored there, and then it will be coming back and showing it whenever it is required. So we'll go and hit the database only once. Irrespective of how many number of records are there, it will go to database only once, bring out all the data, keep it in the buffer, and then they take it from there. But native SQL statement is not like that. 1,000 records are needed, then 1,000 times this will go to the database. It directly goes to the database and hits it 1,000 times. So it will be actually affecting the performance of the database. It will be affecting the performance of the database. Which one? Native SQL statements. But native SQL statements have its own significance. But most of the code that we write are open SQL statements. Most of the code that we write here are open SQL statements. So where does the all the ABAP programs run? All the ABAP programs run in the application layer. Now, after introduction of latest HANA database, these programs are running in the database layer. That is called code to data and all. That we'll see later. So the repository contains all development objects, for example, programs, definitions of databases, and global types. So all development objects created with the development tools found in the ABAP workbench are classified as repository objects. Okay, these all things we'll see later. So the most important thing that we need to understand is this one. And we need to understand one more thing, that a dispatcher distributes the work to work process randomly. It does not say that, okay, I have to run this and I have to send this data to this work process. No, whichever work process is empty or idle, okay, whichever work process is idle, randomly it shows the data to it. Randomly it processes the data to it. Okay. So this is about the three-tier architecture. Remaining things we'll discuss later, but this is about the three-tier architecture. Now, there is a good example which we can remember for a long time, that about the dispatcher. See, so let's say if you have a call center, customer service center, and you give a call to a customer service center, and one representative will pick the call. Next time when you call, same representative might not pick the call, because the dispatch, there also will have a dispatcher. A dispatcher will actually distribute according to the how many number of work processes are there. According to that, it will distribute. Fine. So these are the two things that we have here, which we need to discuss. So there will be open SQL statements and native SQL statements. At this point of time, please remember one thing, that open SQL statements will give less burden on the database, and native SQL statements will give more burden. Now, I don't know whether I told this topic or not, but it's very important for us, not just as an ABAPer, as a software. Anyone who is working on software, they should know the difference between hard disk and database. So did we discuss this difference between hard disk and database? Govind, did we discuss this? Okay, fine. So what exactly is the difference between hard disk and database? So a lot of people get confused about this. I'll give you a very simple example. Okay. Now let's say, can any one of you give your name? If you can just ping me hi, I'll take your name. Govind. Okay, see, Govind has started working in SAP and he moved to US and now he is very successful with very high pay. He gets crores of rupees of salary if it converts into Indian currency. He's happy, but he wants to do something for his village, very small village, remote village, with no internet, nothing. So, but even if he gets the internet, he wants basically to make sure in the village he wants a library because he doesn't want to donate them food or something, because if you donate food it will be going in one day, but library, that knowledge will be there forever if somebody gets a knowledge. So he wants to build a library for all ages from nursery to 80 years. Okay, that's fine. Now he actually books a hall. He has a hall. I mean, like, he purchases one big hall which can be used as a library, and he purchases books, some thousands of books, say 10,000 books. Okay. Now the hall is there and the books are there. Now if he goes to the hall, dumps all these 10,000 books as a mountain. It looks like a mountain. He puts all those books as a big mountain, and he leaves the village. Will that be of any use? Will that books will be of any use? Will you think anyone will open the books and read it? No, the answer is no. Because why is it so? Is because, see, who will have the, and like, how can they search the books in a mountain? They have, for searching only they have to take whole day, and still they're not very sure how do we actually search it. So now Govind has to do one step additional after doing this. He has to, he has to arrange the hall for the library, and once he purchases the books, he needs to also purchase the racks which actually holds all these books, whole books. Okay, so now that is what we have. Okay, so now what we have is library. That's hall. Library means hall. Then we have racks. Then we have books, right? So same way we have, we'll have hall. So hall, in the sense, we'll have the database and the hard disk. Hard disk is just equal into the hall. Hard disk is equal into the hall, and the the what you call database. Is equal into the racks, and books is equal into data. So if you are placing huge amount of data, you need a database to manage that. See, you might come across the situation that you have a 16 GB pen drive or 32 GB pen drive, 64 GB pen drive, and you dump all the information into it, and you keep searching for some file which we fail to get sometimes. We'll forget in which folder I have kept and all this. Just for 64 GB of hard disk, you feel so much confused where one file is been there. But if it is a enterprise data, or huge business data, so it's a very important data, you cannot just dump it in the hard disk. You have to store it in a proper racks. Those racks happens to be database tables. And where are the database tables? They are a part of database. And the best racks, if let's say Govind wants to build a best library, he would have to go for best racks which can have a lot of mechanisms, like, if you buy that racks, they'll be rust free. The rats cannot enter into it. It doesn't book it will not book. So there are a lot of advantages. So that kind of racks, if he purchases, it will be like, that will be definitely advantageous. Similarly, the world's best database has its own advantages. So best databases will be there are very popular databases, SQL database, SQL database, and all. So now SAP also introduced their own database called HANA database, and there are a lot of advantages for it that we'll see later. But this is a very generic term. I have observed that a lot of software employees get confused about this. That's the reason I'm making it clear. Now, what is hard disk? Anywhere we can store the space. So you have an external hard disk also, right? Okay, so here we have this hard disk database and data. Okay, this is what we have. Now, I guess this is clear for you all. So, once upon a time, okay, once upon a time, this three-tier architecture, this database used to be like your pen drive. Okay, so what happens in pen drive? In pen drive, can you, I mean, like, uh, can you extend your pen drive? No, right? Okay, so once upon a time, this database used to be like your pen drive. So we cannot extend the pen drive, right? So we cannot extend the pen drive, and just like that. So it was like that. And then if you have to have additional space in the database, we had to replace this database literally. You understand that? You have to replace this, remove it, and introduce another one. That was the situation there. But later they have introduced the database in such a way that you can just extend it without disturbing the existing database. You can add some multiple additions to it, and we can make that as a central database. Now that technique has come here. So that's the reason in some of the softwares, they call this concept as entire architecture. Entire architecture. Now, when they say entire architecture, it does not mean that they will have n tiers. They will still have three tiers only. Entire architecture. So it will have three tiers only. But all these three tiers can be extended. All these three tiers can be extended. Extended in the sense that the center, you know, the whatever in the front end that we have, the clients can be extended. We can have multiple clients. We can have multiple application tags, and we can have multiple database tags as well. So that is what we can do in the entire architecture. Okay then. So hope you all understood how why it is called entire architecture, because we can extend the database, we can extend the application tag, and obviously we can extend the clients as well. That's the reason it's called entire architecture. It's not in SAP. SAP will never call it as entire. We call it as three tier only. Okay. So when we see SAP software name, once upon a time it used to be called as R3. R3 4.7c. So R3 4.7c. So R3 means and R means real time, three tier. Real time, three tier. So R means real time, three means three tier. Three tier is this one. So they wanted to highlight this in the 1990s. Then it became very common for all the softwares. So they renamed it as SAP ECC. Okay. Now real time means, if let's say, if one, why they call it as real time is, if one department is entering some data, other department can see the data immediately within no time. Okay, that's the reason it's called real time. Okay, real time three-tier architecture. Real time means, now I'm talking and you're listening, this is real time. But if you are listening to this after the recording session, that is not real time. It's like, recorded one, it's non real time. Okay, newspaper is non real time, but live match is real time, something like that is what we have.